Welcome to 4.3 Multiplying Matrices. We're going to multiply matrices and use the properties of matrix multiplication. Start by talking about multiplying matrices. You can multiply two matrices if and only if the number of columns in the first matrix is equal to the number of rows in the second matrix. When you multiply two matrices, the resulting matrix is the dimensions of the outer dimensions, so the rows of A and the columns of B. So here in this first one, we're going to determine whether each matrix product is defined. We're going to state the dimensions of the product. The first one, the inner dimensions are equal, so the matrix product is defined. The dimensions of the product are the outer dimensions, which are 2 by 4. The second one, the inner dimensions are not equal, so the matrix product is not defined. Our key concept here is multiplying matrices. So the idea is the product of two matrices is found by multiplying columns and rows. The entry in the first row and first column of AB is found by multiplying corresponding elements in the first row of A and the first column of B, and then adding. So it's the sum of the products of the corresponding elements in row and column. So we're going to look at an example here. So we want to find RS, which is matrix R times matrix S. It's a 2 by 2, so our final answer will be a 2 by 2. Step 1, we're going to multiply the numbers in the first row of R by the numbers in the first column of S. Then we're going to add the products and put the result in the first row, first column of RS. So here's them being multiplied. What we're going to do is we're going to do 2 times 3 plus negative 1 times 5. And we're going to put that in the first row, first column. Step 2, we're going to multiply the numbers in the first row of R by the numbers in the second column of S, and we're going to add the products. We're going to put that result in the first row, second column of RS. So we're doing 2 times negative 9 plus negative 1 times 7. Step 3, we're going to multiply the numbers in the second row of R by the numbers in the first column of S. Then we're going to add the products and put the result in the second row, first column of RS. 3 times 3 plus 4 times 5. Step 4, we're going to multiply the numbers in the second row of R by the numbers in the second column of S. We're going to add the products and put the result in the second row, second column of RS. So we're doing 3 times negative 9 plus 4 times 7. So here's where we left off. Step 5, we're going to simplify the product matrix. And so there our answer, R times S, is just 1, negative 25, 29, 1. When solving real-world problems, we're going to make sure to multiply the matrices in the order for which the product is defined. So the idea here is a 4-team track meet. 5 points were awarded for first place, 3 points for each second, and 1 point for each third. We're going to find the total number of points for each school and which school won the meet. We're going to find the final scores can be found by multiplying the track results for each school by the points awarded for each first, second, third place finish. We're going to write the results of the race and the points awarded in matrix form. We're going to set up the matrices so that the number of rows in the points matrix equals the number of columns in the results matrix. So first let's create the results matrix, which is what the columns and rows we have right here. So we have 8, 4, 5, 6, 3, 7, 5, 7, 3, 7, 5, 4. That is the matrix we're going to set up for the results. For the points, because this matrix right here in front of us is a 4 by 3, we want our results matrix to be a 3 by something. So our points matrix is 5, 3, 1. 5 for first place, 3 for second, 1 for third. We're going to write an equation where we multiply our R times our P. And then we're going to multiply columns by row. So 8 times 5 plus 4 times 3 plus 5 times 1. 6 times 5 plus 3 times 3 plus 7 times 1. So on and so forth until we finish our columns and rows. Then we're going to simplify to get 57, 46, 49, 54. The labels for the product matrix are shown here. Jefferson got 57 points, London got 46, Springfield got 49, Madison got 54. Therefore, Jefferson won the track meet with a total of 57 points. So some of the properties for real numbers also hold true for matrix addition. However, some of the properties do not always hold true for matrix multiplication. So let's look at commutative property and find out if commutative property works. So what we're going to do is we're going to find the product of P times Q, and then we're going to find the product of Q times P, and we're going to see if they're the same. First off, P times Q. P is a 3 by 2, Q is a 2 by 3. So we're going to multiply and we'll end up with a 3 by 3. So we're going to start by substituting in P and Q to get an equation here. Then we're going to multiply columns by rows, and we're going to simplify to get 30, negative 17, 51, 6, 2, negative 24, 18, negative 3, 15. Then we're going to do QP, which is a 2 by 3 times a 3 by 2. We're going to substitute those in. We're going to multiply the columns by rows. And then we get 78, negative 69, 50, negative 61. Let me simplify. So in example 4, notice that PQ is not equal to QP because the dimensions aren't the same, the corresponding elements aren't the same. This demonstrates that the commutative property of multiplication does not hold matrix multiplication. The order in which you multiply matrices is very important. Now let's check to see if the distributive property works. So the first one we're going to do is A times the quantity B plus C. So we're going to substitute in our matrices. So we have A, which is 3, 2, negative 1, 4, times the quantity B plus C. We're going to start by adding the corresponding elements of B and C. And so we get our A is the same, 3, 2, negative 1, 4. But our new B plus C, that is now negative 1, 6, 1, and 10. Now we're going to multiply the columns by rows. And we get our answer, which is negative 138, 534. Okay, so that was A times the quantity B plus C. Now to see if the distributive property actually works, we're going to do A times B plus A times C. So we're going to start by substituting those matrices in. We're going to multiply the columns by rows. Then we'll simplify, and we get 6, 29, 26, 23, plus negative 7, 9, negative 21, 11. And now we're going to add the corresponding elements. So we get negative 1, 38, 5, 34. Notice that in example 5, A times B plus C equals AB plus AC. This and other examples suggest that the distributive property is true for matrix multiplication. So some properties of matrix multiplication are shown here. The associative property of matrix multiplication works, and the associative property of scalar multiplication works. The left distributive property works, and the right distributive property works. Okay. To show that a property is true for all cases, you must show it is true for a general case. To show that a property is not true for all cases, you only need to find a counterexample. So these are the properties that work. Good luck on the practice.